AMD's new 3D chiplet technology. Is it the future? AMD has already been giving Intel a run, no, a marathon for their money in recent years. And in 2021, it seems like they're taking on full speed ahead as AMD unveiled an industry-changing breakthrough that may convince you to switch once it's available, and some have even called it the future. Before we dive into the video, please do hit the subscribe button and ring the notification bell to be updated with our newest videos. Now, on to the breakthrough. The big reveal happened during Computex 2021 held in Taiwan last June, with the keynote speech delivered by none other than the AMD CEO and President, Dr. Lisa Su. Now today, I'd like to show you the next big step forward. We've worked closely over the last few years with TSMC on their 3D fabric technology to combine chiplet packaging with die stacking to create a 3D chiplet architecture for future high-performance computing products, she announced. Dr. Su then showed to the audience in the webcast a prototype of the chiplet that hosts the new technological development and another standard one to compare and show its differences. This has turned the heads of computer technology enthusiasts, as it is literally one of the biggest takeaways from the presentation of the company. The new 3D chiplet technology that promises to elevate high-performance computing across a long range of applications by a large margin, and most especially in gaming. Can you take a guess on how much? Luckily, AMD was not shy to boast about its latest innovation. Using a prototype Ryzen 9 5800X 12-core processor bonded with the new 3D Vcash chip and both CPUs fixed at 4 GHz, the average performance boost of the system has been north of 15% at 1080p altogether and an unknown graphics card. While this kind of improvement may be decent for some, as it is quite typical with a brand new CPU microarchitecture and process node, the new technology has arrived at the same results only using a 7nm node and Zen 3 architecture that is already in circulation with its current and standard Ryzen 5000 models. And to be specific, the lowest boost was for League of Legends with 4% and the highest being Monster Hunter World, ranking in a running increase of a whopping 25%. Other popular games have also been demonstrated by the AMD team, including Dota 2 with an 18% climb, Gears 5 with a 12% added boost, and Fortnite with 17% in total. And if that's not a large enough performance improvement for you, then I don't know what is. So, how does the new 3D Vcash chip work, you may ask? Developed with longtime AMD collaborators TSMC, we look at the difference of the standard processor, which only carries 64 MB of total L3 cache, while the new 3D Vcash chip features a total of 192 MB available for usage in a single package. To further explain and clarify what's going on, a cache memory's function is to store the most important program instructions and data for the processor to follow at any given time, which means that the larger the cache a computer has, the more data and instructions they can store, because by then, they wouldn't have to ask for more data from the RAM, which then saves up time, thus allowing faster processing. AMD has done this through restructuring the chip's architecture vertically, which is why it's also called Vcash. Get it? Vcash? Okay. So basically, they have managed to assemble a 64 MB SRAM node on CCD, which has then enabled AMD to add more available L3 cache on a, let's say, 16-core processor from 64 MB to a triple maximum of 192 MB. Because of their new approach towards vertical stacking, AMD has also thought about the additional thickness that the new composition may pose for. What they did was that they removed almost 95% of the standard chip's silicon thickness, specifically the CCD and SRAM die, making it similar to the width of a human hair, and then attached the L3 cache on top. This has also enabled almost 2 TB per second of bandwidth for communication between the chip and the cache. And we all have TSMC's 3D fabric technology to thank for that. Dr. Su further discussed that the big leap to this process was made because of a micro-bumpless die-to-die interface that utilizes copper-to-copper bond to help with its thermals, density, pitch, and energy yield. She has even noted that this 3D Vcash technology by AMD is by far the most flexible and advanced active-on-active silicon stacking technology known in existence, with 3 times more improvement in energy efficiency. But because the cache die could not be of the same size as the core complex, AMD added a few more structural silicon to ensure that there would be perfectly equal pressure in both the bottom compute die and the top cache die. As mentioned just a while ago, AMD has not used any microbumps and instead opted to use TSVs, and it's quite a power move for them, as this has not only enabled them to get better bandwidth and power, but also allow the stacking of multiple chiplets at once. Now, this is where Intel can start to sweat. While they do have some sort of 3D stacking technology themselves called Intel Fevros going on, it is very dependent on microbumps between chiplets, which are larger and ultimately eats more power. And you know, for them, it does the job, but there's also an issue with thermals with their design. For starters, you would want the logic on the top die to control the thermals, as it is nearer to the heatsink. But if they would move the logic further from the substrate, the power would have to be taken to the top die. As to the fact that the cache is now very much closer to the core, the latency is something that would be positively affected by its new positional placement. It does also help with accelerating a PC's performance because, as mentioned, there would also be less temperature and a more approximate signaling system. Some other notable features from the new technology come in functionality that makes code compilation even faster, will also speed up rendering processes, and may even increase decompression and compression speeds. With AMD's approach, the new packaging innovation combines 3D stacking with their design, which then gives more than 200 times of interconnection density versus regular 2D chiplets and 15 times more than current 3D packaging technologies existing in the market. But what innovations have we all considered without weighing in some criticisms, right? Well, some have pointed out that the demonstration of the Vcash has only shown us a part of what AMD is claiming. They have only shown us the increase in discrete and integrated gaming and nothing else for other applications. Some have brought up the idea that an increase in L3 cache depth does not do much for overall performance, and even pulled up AnandTech's review of the Intel Broadwell processors with 128 MB of L4 cache, and so far, gaming and compression and decompression tests were the only portions improved in the computer's whole performance. So would this AMD 3D chiplet technology have the same reputation? Would Intel's Broadwell processor translate right back to AMD's? Is AMD leading us on for what we are hoping for? Well, we're bound to find out anyway. Though it was not a secret that AMD has been putting in the work with TSMC's 3D fabric technology, most people were surprised and did not even expect that the product would come this soon, or that it would even be done with a full-on demo on a desktop processor. According to Tom's Hardware, AMD has confirmed to them that the new 3D chiplet technology with their new Zen 3 Ryzen processors will come into production by the end of the year, and other technology blogs and journalists think that it would be available on the market at least by the end of February 2022. Our first application of 3D chiplet technology at Computex demonstrates our commitment to continue pushing the envelope in high-performance computing to enhance user experiences significantly. We are proud of the deep partnerships we have cultivated across the ecosystem to power the products and services that are essential to our daily lives, Dr. Su acknowledged. Well, a lot of PC enthusiasts are now on the edge of their seats to see if AMD has truly done it again, and some are now even contemplating whether they would make the switch or not when it finally comes out. What do you think? Would you like to try out AMD's innovation? Comment your thoughts down below and make sure to like the video, hit the subscribe button, and ring the notification for more amazing videos from us.